Okay, this was the next slide that we skipped during class, so let's go through our reasoning for this expression for the kinetic energy. So for this, we'll suppose that we have a single force F acting on an object of mass m in the direction of motion, so they're parallel to each other, and that the object travels a distance d starting from rest. So you have some object whose v initial is equal to 0, then it travels some distance d, then its v final is equal to some velocity v, and throughout we have a force acting in the direction of motion. Okay, so now we want to find, basically we want to see how much work is done, what's the velocity going to be at the end of this distance d. So first of all, we know the work done is simply force times distance, because the dot product, F dot d, so we know work is equal to the force dotted into the displacement vector. Since they are parallel to each other, the angle between them is 180 degrees, so cosine, or sorry, not 180, 0 degrees, and cosine of 0 degrees gives you a 1, so we essentially end up getting it's F times d. Then, remembering kinematics, we know v final squared is equal to v initial squared plus 2a delta x. Well, we're calling v final some v, so v squared. We know v initial 0 because this thing started at rest, so 0 plus 2a, and then the delta x, in this case, we've labeled it to be some distance d that it's traveling. So basically, the final velocity of this object is going to be 2ad, and I'm going to go ahead and apply, so the acceleration that this object experiences in this direction is just the force divided by mass. So I'm going to go ahead and replace a with f over m, so we get 2f d over m square root for the final velocity of this object. Now rewriting this, I'm going to isolate f times d. So first I square both sides, multiply both sides by m, divide by 2, and I get on the right hand side I have left f times d. So now basically what we're seeing is the work done by this force is summing up to give us this expression mv squared over 2. And this is basically what we're calling the energy of motion, or the kinetic energy. So this force did work on this object of mass m and then gave it energy of motion. Basically, it went from rest to traveling at some velocity v, and we know the energy stored just from using Newton's second law and kinematics is equal to 1/2 mv squared. So that is something we didn't get a chance to go over in class.